High volume air conditioning in the future. Progress. Time marches on, and it is relentless. What was new last year is not new anymore. What worked in the area of home and building heating and air conditioning installation in the past is not necessarily what will be happening in the coming years. At Freedom Heating and Cooling, we take a great interest in learning about new technologies, new installation procedures, and new ways to provide maintenance to existing home or building units. The Department of Energy. We are 2 years into an investment process begun by the Energy Department's Office of Energy Efficiency and Renewable Energy. This department is responsible for energy efficiency and the creation of new technologies along with solutions that enhance the American use of energy in various venues and markets. The department also takes a great interest in the vitality and quality of the American economic system. In 2015, the Department of Energy invested $8 million to encourage research in the areas of heating, ventilating, and HVAC technologies. The goal was and is to save expenditure on energy costs and decrease the use of harmful chemicals that can have a negative impact on the environment. This is important as HVAC systems in buildings account for 14 quadrillion British thermal units, or quads, of primary energy annually. This represents 30% of the total energy expenditure in the U.S. The allocation of $8 million was focused on developing advanced non-vapor compression HVAC systems and advanced vapor compression technology. It is projected that non-vapor compression technologies will use 40% less energy than other systems. Advanced vapor compression. Vapor compression uses a circulating liquid refrigerant as the medium by which heat is absorbed and removed from a space that must be cooled. A vapor system consists of 4 components. Each system has a compressor, a condenser, a thermal expansion valve, and an evaporator. Non-vapor compression. Research into alternative methods of non-vapor compression have been financed by the Department of Energy. Some of these alternative methods are so new they are still in laboratory phases of the research process. Some of the methods have not made it to market, but are being analyzed for future use. Essentially, these alternative methods may be classified into solid-state technologies, electromechanical, and thermally driven technologies. Solid-state technologies. These technologies produce temperature differences based on the intrinsic capacity of material properties within the system after being activated by electricity. Technology based around magnetocaloric properties has produced a prototype. Thermoelectric materials generate a temperature change, but are only adequate for low-capacity commercial use. Thermotunneling transmits electrons across a nanometer-scale vacuum by quantum tunneling to produce temperature change. Electromechanical technologies. These processes are driven by electricity and alter the phase of a working fluid. The Brayton cycle heat pump generates heating and cooling by compressing and then expanding gas using turbo machinery. Evaporative coolers use liquid water to absorb heat from the air. Thermoacoustic heat pumps oscillate using helium fluid and high-amplitude sound waves to generate temperature change. Thermoelastic processes transfer and change temperature by the use of a shape memory alloy or polymers to absorb heat and transfer it to other areas. Thermally driven technologies. These technologies use thermal energy as the primary force to drive a heat pump. An absorption heat pump uses a refrigerant absorbent fluid pair and an energy source to drive a heating cooling cycle. An adsorption heat pump uses a porous material to adsorb or capture a refrigerant. A duplex Stirling heat pump uses mechanical energy generated by a gas-fired Stirling engine to compress and expand a refrigerant. An ejector heat pump accelerates a refrigerant through a nozzle using a high-pressure refrigerant. An evaporative liquid desiccant air conditioner consists of a primary channel that cools a layer of air using a liquid desiccant stream. A ground-coupled solid desiccant employs two processes. The primary stage dries the supply air using a solid desiccant wheel, and the secondary stage cools the air using a ground-coupled fluid loop. A standalone liquid desiccant AC uses materials that absorb water from the atmosphere. They only dehumidify. A Volumir heat pump uses a gas-fired heat engine to compress and expand a fluid to produce a hot and cold side. Companies supported. These companies have received money from the Department of Energy since 2015. United Technologies Research Center in Connecticut received $975,000 to finalize the presentation of a centrifugal compressor that will make 1.5 to 10-ton rooftop systems more efficient. This company also received $1 million to work on an electrocaloric heat pump that is 50% smaller than others in the same category. Mechanical Solutions Incorporated in New Jersey will share $1 million with Lennox Industries Incorporated to develop a centrifugal compressor designed to be used in 4 to 5-ton systems. Their solution could also be used in 20-ton systems in the future. Deus Analytic in Florida received $1.2 million to do membrane HVAC technology using nanostructured polymer materials to manipulate water molecules. This system will do away with fluorocarbons. Maryland Energy and Sensor Technologies, LLC, in Maryland received $600,000 to develop a compact thermoelastic cooling system. Oak Ridge National Laboratory in Tennessee received $1.4 million to develop a magnetocaloric air conditioner. This system moves copper, brass, or aluminum rods in and out of a magnetic field that alternately gain and lose temperature. Exergy Incorporated in Delaware received $1.4 million to develop electrochemical compression technology along with an energy recovery module to replace a solid-state compressor. These companies, along with others, are attempting to reduce the average expenditure for high-volume air conditioning. Each offers its own particular technology, and only future events and allocation of funds will show exactly which technology will make it to market. Research has been done to show which technology might actually make it to the end user. The following is a precise listing of the technologies being supported and their categorization from most promising to least promising. Coming in at the top of the list is thermoelastic, then membrane heat pump, evaporative liquid desiccant AC, magnetocaloric, Volumir heat pump, evaporative, thermoelectric, ground-coupled solid desiccant AC, absorption heat pump, duplex Stirling heat pump, thermoacoustic, adsorption heat pumps, thermotunneling, standalone solid desiccant AC, standalone liquid desiccant AC, ejector heat pump, and the Brayton heat pump. If you have questions related to any of these future events that will be happening in the HVAC industry, or if you just have questions about your own home, call Freedom Heating and Cooling at 205-444-4444.